Deep field images from the James Webb Space Telescope are filled with hundreds of compact crimson specks scattered across the universe as it existed 13 billion years ago. Astronomers have named them little red dots. These objects are incredibly small, roughly 1,000 times smaller than our Milky Way galaxy, but they create a mass paradox. To produce their specific red glow, that tiny volume must contain up to 100 billion solar masses of stars. If these objects are indeed galaxies, they represent a density of stars that exceeds every established limit of cosmic scale. Our standard model of cosmology, lambda CDM, dictates that dark matter and gas need billions of years to assemble into structures this massive. But we are seeing these objects just 600 million years after the Big Bang. Treating these as galaxies leads to a physical impossibility. The stellar density would be so high that stars would be physically colliding with each other on a monthly basis. The math presents an ultimatum. At this specific point in the cosmic timeline, these objects contain more baryonic mass than the total matter available in the dark matter halos where they reside. Either the timeline is wrong, or these specks aren't made of stars. To identify the real power source, researchers used JWST's near-infrared spectrograph to analyze the specific light signatures hidden in those pixels. The data revealed a V-shaped continuum with unusually broad peaks located at the Balmer hydrogen frequencies. Those broad peaks indicate hydrogen gas whipped into a frenzy by a massive gravity well. It's moving at relativistic speeds of up to 4,000 kilometers per second. This motion is the hallmark of an accretion disk feeding a central supermassive black hole. Attributing the light to a single central engine instead of billions of stars drops the required mass of the system by a factor of 10, bringing the objects back into alignment with cosmological models. But the black hole solution immediately created a new contradiction. A feeding supermassive black hole should emit a massive, detectable signature of high-energy X-rays. Our most powerful X-ray telescopes have looked at these exact coordinates for decades and detected nothing. This invisibility is caused by a unique form of obscuration. These black holes lack the typical dusty torus. Instead, they are encased in a spherical cocoon of dense ionized gas. In this black hole star model, the gas envelope is thick enough to trap high-frequency X-rays through repeated scattering. Only the longer infrared wavelengths can leak through the outer boundary to reach our sensors. This creates a thermal profile that perfectly mimics the atmospheric glow of a dense, cold star. For years, these black holes were able to avoid detection by adopting a stellar masquerade. The true scale of this population is only now becoming clear. The early universe hosted a massive, previously hidden population of these overmassive black hole seeds. There are 10 times more of these obscured engines than standard evolutionary models predicted. Their number density is roughly 1 for every 100,000 cubic metaparsecs of the early universe. These idling giants sat in the dark for eons, effectively bypassing every traditional astronomical detection method because they lacked X-ray and radio signatures. Even while hidden, they were active. JWST detected unusually warm molecular hydrogen here, proving they blasted kinetic shockwaves into their host galaxies. These engines use that feedback to heat gas and suppress star formation, effectively manipulating the very fabric of. The anomalies we discovered in the early universe are baby supermassive black holes. This creates a physical contradiction. If these black holes have the mass of millions of suns, they should be emitting high-energy X-rays. Yet for decades, our most advanced X-ray telescopes saw absolutely nothing. To find the source of this silence, we have to look past the macroscopic galaxy. We need to zoom in on the environment immediately surrounding the black hole. The mechanism that keeps these entities invisible from Earth is the same force that destabilizes their environment up close. These early black holes were born buried inside a dense cocoon of warm molecular hydrogen gas. This gas layer acts as a physical wall. High-energy X-ray photons are trapped inside, ricocheting back into the core and hiding the black hole from our instruments. While hidden, the black hole is undergoing super-Eddington accretion. It is consuming the surrounding gas envelope at a rate faster than is theoretically stable. Forcing that much matter into such a confined space generates immense friction. This produces heat, which radiates as the extreme optical redness detected by the James Webb Space Telescope. Even as the object appears calm from the outside, the internal pressure within this gas cocoon continues to rise. That heat and radiation eventually push outward, into the host galaxy itself. The radiation from the feeding frenzy violently ejects the surrounding gas, rather than pulling it in. Gas is whipped outward at speeds reaching 2 million miles per hour. This velocity creates kinetic winds that act as a structural shockwave, blasting directly through the black hole's host galaxy. Overfeeding at the core triggers an explosive starvation event for the rest of the host galaxy. Astronomers use the inside-out growth hypothesis to explain this. A massive outward-moving ring of force clears the central region of particulate matter. These kinetic winds act as a cosmic bulldozer, expelling gas and dust required to form stars, leaving the center empty. This forced relocation evicts starbirth, pushing new stellar formation to the extreme fringes. The black hole is bulldozing and reshaping its own host galaxy from the inside out. This influence extends beyond the host galaxy and into the intergalactic neighborhood. Kinetic winds and radiation continue traveling through deep space, far past the borders of the galaxy. This radiation travels millions of light years and pierces neighboring unformed gas clouds. The radiation splits molecular hydrogen in these clouds, sterilizing them and suppressing their ability to collapse into new stars. Little red dots acted as cosmic predators, dictating exactly where starbirth could occur in the early universe. These entities reached a point where they disappeared from the timeline 1.5 billion years after the Big Bang. The relentless kinetic winds eventually blew away the black hole's own obscuring gas and dust. Without the thick red cocoon to hide them anymore, the central black holes are completely exposed as brilliant, piercing blue quasars. The structure of the universe we recognize today is the result of this violent, temporary phase of early black hole evolution. The most massive, galaxy-shaping structures in the cosmos began as these smallest, seemingly insignificant dots. Keep looking up and stay curious.